everyone, and welcome to our lesson on sequences. Sequences are lists of numbers that follow some kind of pattern. So we'll take a look at a few of those examples in a minute. And you also need to know that when we're talking about any one number in that sequence, we're talking about a specific term or an element. Okay, so when we're referring to one item, that may be referred to as a term or an element. All right, let's take a look at a few examples. So we have a list here, 1, 3, 5, 7, 9. So what you'll do is you'll take a look and identify and see if you can find out the pattern that it's following. We can see here that from 1 to 3, 2 has been added. And to get from 3 to 5, the next term, another 2 has been added. So it looks like this pattern is adding 2 each time. Okay. All right, next one here. We've got 2, 4, 8, 16. Okay, I can see that we're not adding the same amount each time. Maybe something else is going on. So from 2 to 4, I can get there by multiplying by 2. Let's see if that works to get to the next term. 4 to 8, I can get there by multiplying by 2. Okay, let's put a multiplication symbol out here so we'll know we're not adding. And from 8 to 16, I just want to check and make sure that follows the same pattern, and it does, multiplying by 2. So this sequence has rule of multiplying by 2 to get to each new term. All right, third one here. I can see 1 is the first term, and then 1/2, and then 1/4. So it doesn't look like an adding or subtracting sequence here. From 1 to 1/2, I have to multiply by 1/2 to get there. Okay. And let's check and see if that's the case to get to the next one. From 1/2 to 1/4, I would multiply by another 1/2. So it looks like the pattern that's being followed here is a multiplication pattern, specifically by 1/2. All right, and then last one here, these are going down in value, -100, -200, -300. So that looks like maybe an adding pattern, but we're adding a negative amount since we're decreasing down by 100 from one term to the next. So we can say subtracting 100 is the pattern there. All right, so there's just some different types of sequences you might come across. All right, when you're looking at a list of numbers that form a sequence, you can find additional terms by looking at the explicit rule or the recursive rule. So I'm going to go over each of those. You can also develop one of these rules if you can see a pattern forming. The explicit rule works like this. If you can see the sequence and you can see you can either be given the rule or you can develop the rule, you can use that rule to find any term that you want to in the sequence by plugging that number in for n, okay, or the variable that they've used, n or x, whatever has been used. For the recursive rule, that is using each term to find the next term by the one that came before it. So you're using the one that you found to find the next, and then you're going to use that one to find the next, and so on. So it will make more sense when we see an example about the difference between those two methods. Let's take a look at the explicit rule first. I've been given a rule here for a sequence, f of n equals n squared plus 2. So that means to find each term here, I'm going to plug in a number for n, like 1, and that will give me that term, the first term. If I wanted the second term, I would plug in a 2, and that would give me the second term, just by calculating out according to the rule. So we're going to do that. We want the first 3 terms that would be in this sequence. So I'm going to have 1 squared plus 2 to give me the match for 1. And then I'm going to try 2 squared plus 2 to give me the second term, and then 3 squared plus 2 to give me the third. All right, so 1 squared plus 2 is going to give me 3. 2 squared plus 2, 4 plus 2 is going to give me 6. And then 3 squared plus 2, 9 plus 2 is going to give me 11. So I can fill this out here. So 1 gave me 3, an n value of 2 gave me 6, and an n value of 3 gave me 11. So my first 3 terms in a list for this sequence would be 3, 6, 11, and I could continue and find as many as I need to, or any higher term, maybe like the 50th term or the 100th term, just by using this rule and plugging that in for n. All right, using the recursive rule works a little bit differently. Remember, we're going to find each term by the one before it. Okay, so let's say that we would like to find the first 3 terms of a sequence, and we know that the first term is 4, and each term after that is going to be found by taking the one before it and subtracting 3. Okay, that's how we're going to read this here. F of n equals f of n minus 1, that means the term before it, minus 3. Okay, so we know the first term is 4. That's been given to us. All right, so let's say we want to find the second term. We're going to follow this rule here. It's telling us that the second term is going to come from taking f of 2, since that's my n, minus 1, and subtracting 3. All right, so f of 2 minus 1 is f of 1. I'm just doing the math inside the parentheses there. And we know f of 1, we were given that. That is equal to 4, so I'm going to substitute that in here for f of 1. And now we know that the second term is 1. All right, so second term is 1. All right, we need to do the same thing to find the third term. All right, so f of 3. Let's draw a line here, do some work down here. F of 3 is going to be found by following the same rule, f of that number minus 1, and then subtracting 3. Okay? So f of 2 minus 3. Okay, our f of 2 we just found, it's 1, so I'm going to substitute that in there for f of 2. Okay, so let's move over here. So that equals 1 minus 3, which gives us negative 2. Okay, so the third term is negative 2. So here would be our first 3 terms in that sequence, and we found those using the recursive rule. So let's make sure that we did end up with a pattern here. So from 4 to 1, that is a subtraction of 3, and from 1 to negative 2 is also a subtraction of 3. So it looks like the pattern that would be formed by this sequence is subtracting 3 each time. Okay, one other thing that you may be asked to do, that you can do for any sequence, is put it on a graph, see the visual of what's happening. And anytime you need to do that, it's very simple. You're just going to number your terms that you're given. Starting with the first one, just treat the first one as the first term. So I'm going to come up above them and number them 1, 2, 3, 4, and 5. And if you're given more, you can continue. And I'm going to treat these as XY pairs now, and then I can graph the sequence that way. So these are my x values, these are my y's. Let's put that out here. So I've got the point 1, 1, which is going to be here. Then I've got 2, 3. So I'm just going to go put these here. Then I've got 3, 5, 4, 7, and 5, 9. And one reason why you may want to graph a sequence, or may be asked to, is just to see what kind of picture we're going to be given. What kind of shape is it making? If it's a steady increase, you know that that's a steady amount that's being added or subtracted each time in your sequence. If it's not, it may be a multiplication sequence. Okay, so ours, it looks like ours is forming a very steady relationship here, a linear relationship. So we can see that from one term to the next, we're adding the same amount each time. All right, and that concludes our lesson on sequences.